Yeah. So what we'll do is we'll complete colloids first, solve its MCQs, and then begin with coarse dispersion. I had given you all some pre-reads. Did you all go through that?
Yes, ma'am.
For coarse dispersion. And colloids के भी
Yes.
notes upload किए हैं. So that you all went through?
Yes.
Everyone understood? Any doubts in that? Any doubts in that? Hello?
No, ma'am.
I'll expect you all to give a reply at least. So what we'll do is we'll begin with the second part of colloids. So let me know once you start seeing the screen. Yeah, can you all see the screen?
Yes, ma'am.
Yes.
All right, great. So yeah, last class we began with what are the fundamentals of colloids. We discussed the different types, categorization of dispersed system based on its size. Then we categorized this, understood about why blood is a complex dispersed system. Then we categorized dispersed system based on its dispersed phase and medium, the different names which we went through. It's important to understand what a solid foam is. Foam matlab gas is being entrapped. All right. Aerosol matlab gas is the medium. Simple. All right. Then specific surface area ka importance, then purification ke steps, then shape का क्या role है, okay? Shape का क्या role है, and then the different types of colloids, all right? Lyophilic, lyophobic, and which are the means of making them, right? Association colloids. And then we also started with some properties, right? We also had an overview of the discussion, correct?
Yes.
So now let us look into it a little in detail. So the first property of colloids, which is important, the one which is important and we are going to discuss, is about the Faraday-Tyndall effect. All right. So the Faraday-Tyndall effect kya bolta hai? It's an optical property. Optical property means it has something to do with the light. All right. It has something to do with light. So मैंने last class बोला था कि optical property में there are these two important things. So light scattering is a result of Faraday-Tyndall effect. Faraday-Tyndall effect क्या बोलता है कि कुछ भी जब हम colloidal dispersion ले, okay, so that will cause scattering of light because they are nothing but particles, right? So that will cause scattering of light. Okay, so it's actually the same thing only. And so these are the two scientists, Faraday and Tyndall, who studied this effect. It's also called as the Raman effect, right? Scattering of light was also studied by Raman, C.V. Raman, an Indian scientist. And he was in which institute? Any idea? Rocket Boys देखी है series तुम लोगों ने? So C.V. Raman study, हाँ देखी है?
No, ma'am.
Okay, you all should watch such series. So
Ma'am, it is related to the moon, right?
no, it's not related to moon. Rocket Boys is about the atomic power mission of India led by Dr. Homi Bhabha and about the space mission which was
Okay.
initiated by Sarabhai. You all should watch that. So anyways, C.V. Raman and even Dr. Homi Bhabha, they were leading scientists at IISc Bangalore. All right, so these discoveries were made that pre-independence. Okay, this was pre-independence. Anyway, so this was some like just some GK about it. So what they studied is that if you see here, this is plain water. Okay, even this is initially plain water. So there is इतना ही light है. But यहाँ पे जब solute मिलाया जा रहा है, okay, when solute is being mixed, you saw light का spectra कितना बढ़ गया. First it was this much only, a single point of light. Then after mixing things, the light का area, circumference बढ़ गया. This is because of scattering of light. When you have some solute particles or some dispersed particle, which is not a solution, okay, which is not a solution, when you have dispersed particles and when light travels, it will scatter light, okay, light will be dispersed. And that is why you have a bigger area of the light, scattered light, all right. So based on this principle, another scientist called Zsigmondy, he developed an ultra microscope. This is an image of ultra microscope, all right, wherein you keep your sample here. Either say light beam aata and either say you can view your you can view the sample. All right, so what he says is the cell containing the colloid cell bhi maine bola tha na, the protoplasm is also colloidal. Okay, so when you view it against a dark background at right angles, okay, the particles which exhibit Brownian motion, and Brownian motion kaun exhibit karega? The colloidal particles. All right, so those will appear as spots of light against a dark background. Matlab when you in an ultra microscope, jab tum kuch colloidal substance rakhte ho against a dark background, it will appear as light ka spots. Fine. And this is also a technique which is used for measuring particle charge during microelectrophoresis. Fine. So this becomes very important, this optical property. And मैंने last time एक DLS instrument का भी बोला था ना, dynamic light scattering instrument. So dynamic light scattering instrument के वजह से क्या होता है? All right. As the name suggests, even it works on the principle of light scattering. Dynamic light scattering, जिसमें तुम्हारे cuvette होता है, जिसमें you have your dispersed phase and your dispersed phase in a random motion. Okay, it's in a random motion. Fine, random Brownian motion में होता है, and during this, and that is why it is dynamic. Dynamic because it's constantly under motion. Dynamic light scattering के वजह से this you can also determine the molecular weight of colloids. Molecular weight of colloids. You can also determine the size of colloids. Shape B you can determine. And DLS instruments, you can also determine the zeta potential, the electric property. All right. So these are some things which can be done. It becomes very important to study your proteins, polymers, all your nanoparticles, liposomes, AAVO, and everything. Understood?
Yes.
Yes, ma'am.
Okay. Then coming to the kinetic property, which is like very easy. We've been studying this since a very long time. So first is the Brownian motion, which is the random movement of your particles. Okay, random movement. There's no particular path of this particle. And this random movement of the particles, it's further aggravated by the collision. एक दूसरे के साथ colloid होके जा रहा है. अभी ये if it's going up here, इधर से अगर कुछ टकराया तो it will change its path. इधर से कुछ टकराया, it will again change the path. So it's literally random. Fine. So the irregular and the zigzag path, all of this is very complicated, and this was studied by scientist Robert Brown, and that is why it is called as Brownian motion. Then the second is diffusion. 1 minute, why isn't the animation? just a minute. हाँ, diffusion में if you see, एक corner से particles are going in another direction. So from a higher concentration of solute, it's going to an area of lower concentration. Okay, and this is also spontaneously, but there has to be a gradient. This will take place when there is a gradient. Fine. Higher concentration to lower concentration until the concentration of the system is uniform throughout. Matlab, eventually it will attain equilibrium. Fine. This is the thing. Brownian motion mein, acha, now tell me, Brownian motion, if your dispersion is very concentrated, Brownian motion zyada hoga ki kam hoga? Hello.
If the viscosity is low, then Brownian motion will take place, and if viscosity is high, then it was low.
Okay, viscosity, you said viscosity is inversely proportional to Brownian motion. Fine.
Yes.
What about concentration?
If concentration is high, then Brownian motion will take place more.
No, even this is inversely proportional. ज्यादा concentration होगा तो movement के लिए जगह ही नहीं रहेगी. Imagine this is more, there are more particles here, more particles here. Will it have enough space to move? No. जितना ज्यादा concentrated होगा ना, उतना Brownian motion कम होते जाएगा. The degree of Brownian motion. What about temperature? Temperature is directly proportional, inversely proportional.
Inversely proportional, नहीं, directly proportional. Sorry.
मतलब?
If temperature is high, then Brownian motion will be more.
Correct. Why?
Because
Why?
at the boiling water, like the movement of particles will take place because of the heat.
Can you say it in a scientific way?
As the heat provides the molecule move in the random kinetic motion, because kinetic energy is applied on the molecules.
Thank you. Thank you. This is the way you need to explain this. तुम thermal energy provide करोगे जितना ज्यादा तो molecules में वो energy will be absorbed and it will increase its kinetic energy, and that is why kinetic मतलब क्या? Energy which is related to motion. All right. So viscosity and concentration का inverse relation है, temperature का direct relation. Understood everyone? With respect to Brownian motion. Diffusion में what is it? Movement from higher concentration to lower concentration. That is the gradient. Concentration gradient होना चाहिए. Okay. There should be concentration gradient. And it will happen till the time equilibrium is achieved. Fine. Then the next one is osmosis. Osmosis में क्या होता है? First of all, there is a semi-permeable membrane. All right, there's a semi-permeable membrane. And here, there is a movement of solvent molecules. Okay, there's a movement of solvent molecules. Now here you see, either तुम्हारा solute का concentration is more. Solute का concentration is high. And this is low solute concentration. Fine. लो सल्यूट कॉन्सेंट्रेशन मतलब इधर तुम्हारा सॉल्वेंट ज्यादा है. सो इन दिस केस व्हेन योर एक कंपार्टमेंट में सल्यूट कॉन्सेंट्रेशन ज्यादा है and if it is separated by a semi-permeable membrane, there will be a movement of water like this from a region of higher concentration, from a region of lower concentration of solute to a region of higher concentration of solute. Okay. So osmosis is nothing but the movement of solvent molecules. Okay, movement of solvent molecules from a region of dash concentration
Lower
of
concentration to higher concentration.
correct, from a region of lower concentration of solute to a region of, I hope you all are writing it down, to a region of higher, whatever I'm writing won't come in your slides, so please write it down. To a region of higher concentration of solute. Am I missing something here?
Solution.
Through a,
Semi-permeable membrane.
yes, through a semi-permeable membrane. We will take up interesting case studies when we are doing parenterals, when we are doing parenterals, because parenterals mein, okay, and when through a semi-permeable through a semi-permeable membrane, again till equilibrium is achieved. ठीक है? Till equilibrium is achieved. So this happens in a blood also. So blood में तुम्हारे जो RBCs होते हैं, okay, in blood when we have these RBCs, if तुमने जो injection दिया है, if suppose that is hypertonic, माने if there are more solute molecules, तुमने जो infusion दिया, this is your blood stream, all right, blood stream में तुम्हारे RBCs है, RBCs में भी अपना कुछ concentration होगा, correct? RBCs में भी you will have some concentration, and this RBC का membrane is a semi-permeable membrane, obviously, okay, all these are semi-permeable membrane. Now tell me, अगर इधर concentration ज्यादा होगा, बाहर अगर concentration ज्यादा होगा compared to अंदर, तो how will the movement be? किस चीज का movement होगा? पहले तो ये बोलो.
RBC content.
RBC कंटेंट का मूवमेंट होगा कि वाटर का मूवमेंट होगा? तुम्हारा ब्लड में भी यू हैव प्लाज्मा, RBCs में भी यू हैव सम अमाउंट ऑफ वाटर, तो किस चीज का मूवमेंट होगा? वाटर का मूवमेंट, वाटर का मूवमेंट होगा. नाउ टेल मी, अगर बाहर हाई कॉन्सेंट्रेशन है, अंदर लो कॉन्सेंट्रेशन है सल्यूट का, तो कहां से कहां मूवमेंट होगा?
अंदर से बाहर.
ऐसे?
यस.
करेक्ट. एंड सपोज बाहर लो कॉन्सेंट्रेशन है एंड अंदर हाई कॉन्सेंट्रेशन है, तो
बाहर से अंदर.
ऐसे? करेक्ट.
यस.
नाउ इफ दिस हैपेंस, इफ आरबीसी के अंदर पानी बढ़ता जाएगा, it will swell up and eventually it will burst.
Apoptosis.
Apoptosis नहीं, hemolysis. Apoptosis is the natural cell death. Hemolysis is the lysing or the breaking of the RBCs. Okay, hemolysis, not apoptosis. Apoptosis is a chemical reaction. This is a biophysical phenomena, osmosis. Okay, so in case of hypotonic solution, hemolysis हो जाएगा, and in case of hypertonic solution, all this water will go and it will become flaccid. Both of these are not favorable. Both of these are not favorable. That is why तुम्हारे जो भी parenteral formulations होते हैं, it should be isotonic. Isotonic मतलब बाहर भी same amount of concentration होना चाहिए, अंदर भी same होना चाहिए, and that is why there will be an equilibrium maintained, so there won't be any hemolysis of flaccidity, because this can cause a lot of damage, right? Obviously, this is not favorable. So isotonic होना चाहिए. तो हमारा blood का isotonicity या osmolarity is about 320 milliosmoles. That is why you need 0.9% weight by volume of NaCl solution to make your injections isotonic. Because iska isotonicity, iska osmolarity, and iska is almost similar. Fine. We'll study this in detail in parent trials. But ye samjha sabko, why is osmosis so important?
Yes, ma'am.
Good. Now, one more thing. I hope you all have written this.
Yes.
Yeah. Abhi, one more thing which we will, I would want to discuss is about reverse osmosis. Reverse osmosis. So reverse osmosis में क्या होता है? Again, you have a semi-permeable membrane. So here you have low concentration, and here you have high concentration. Okay, here you have high concentration. So osmosis में क्या होगा? What will normal osmosis be?
From low concentration to high concentration.
From compartment A to B. All right. But as the name suggests, this is reverse osmosis, right? So reverse osmosis में क्या होता है? मैं इधर pressure लगाती. I will apply pressure here, and the movement of water will be like this. Reverse हो जाएगा. Again through a semi-permeable membrane. And this is what your RO purifiers are. RO purifiers. RO water purifiers होते हैं ना, ऐसे ही होता है. Because ये जो बाहर का पानी होता है, that has lot of salt content, salt, minerals, and all of that. जो तुम्हारा tap water होता है, गांव में जो पानी आता है, lot of hard water होता है ना. Why is it called hard water? Because it has a lot of salt and mineral content. Okay. So to make it a little more potable and more drinkable, okay, reverse osmosis की machines लगाते हैं, wherein osmosis का जो regular process है उसको reverse कर दिया था. Understood everyone?
Yes, ma'am.
And here there'll be outflow of water in the reverse osmosis ka machine. There'll be outflow, so that the equilibrium is not maintained. Okay, it will be more towards this side, क्योंकि यहाँ से पानी निकलता जाता है, so this will always be at a lower concentration. अगर ये दोनों equal हो गया तो there won't be movement, so it's not kept equal. The equilibrium is maintained towards the lower concentrations. All right, clear everyone?
Yes, ma'am.
Okay, fine. So these were about the kinetic properties. Then moving to electrical properties. Okay. Colloids usually have charge. Mostly they have a lot of charge on their surface. So because of that, it's crucial to understand their electrical properties. So the first property is electrophoresis, or uska bhai bandhu is electroosmosis. We'll study these two together. So electrophoresis में क्या होता है? There is a movement of charged particles. Okay, there's a movement movement of particles through a liquid under the influence of applied potential. Applied potential difference होता है. Applied potential मतलब तुम potential difference apply करना मतलब electricity apply करना. Positive and negative electrodes. All right. So what is happening is that you keep your electrophoresis कैसा होता है ना, agar gel रखते हो तुम, उसमें तुम तुम्हारे samples load कर. Fine. And उसको एक water medium में रखते हो. So this is all covered in water. All right. So when you apply a potential difference, say इधर तुमने positive charge apply किया, इधर negative charge apply किया, हम apply कर रहे हैं. So there will be a movement. Okay. If this is a negative, if this is a positively charged component, it will move more towards the negative electrode. If this is more negative, it will stay here only. If this is a little in between, it will travel only thoda. Okay. So based on the migration ke kitna move ho raha hai, we can understand what is the charge on that colloid, or we can also understand how much is the charge, what is the degree of the charge. Okay. So as the direction and the rate of migration, and if something is move, so idhar se hame direction bhi pata chal raha hai ki wo idhar move kar raha hai ki is it just staying where it is, kitna tezi se move kar raha hai wo bhi pata chale. Okay. So the direction and the rate of migration will help us in determining what is the sign, matlab is it a positive or a negative moiety, and how much is the magnitude, kitna positive hai, kitna negative hai, okay, of the zeta potential in a colloidal system that can be detected. So this is electrophoresis. Electro-osmosis mein kya hota hai? There is a liquid moves through a plug or a membrane of solid, which is to which a potential difference is applied. Fine. So यहाँ पे solid is moving. यहाँ पे your particles are in a solid form. यहाँ पे your sample is in a liquid. Liquid is moving. So you have, say, a plug of solid. This is a membrane, or this is something through which your liquid can move. Again, this is positive, this is negative. और तुम ऐसे pass कर रहे हो, तो कितना तेजी से move कर रहा है, कैसे move कर रहा है, the rate of flow of liquid. Okay, that helps in determining the zeta potential and all of that. Fine. So in both the things, you are applying potential difference, and in electrophoresis, solid is moving. In electro-osmosis, liquid is moving. All right. But तुम दोनों में charge you are applying. So there is an applied potential difference. Coming to sedimentation potential and streaming potential. अभी इसमें उल्टा होता है. इसमें you are not applying anything. You are just moving, letting the sample move. And because of their movement, a potential difference is being generated. Okay. So there is a creation of potential when particles undergo sedimentation. Say you have your particles here, okay, and when they are eventually settling as in when they are eventually sedimenting, if they are, say, negatively charged, so there will be more of positive charge left here, and there will be an increase in the negative charge here. Eventually, when all of this settle here, there will be a lot of negative charge here. Okay. So when particles are undergoing sedimentation, they create that potential. Streaming potential may same like this thing, which will be when you force a liquid through a plug or bed of particles, there will be a creation of charge. Understood, everyone? So even this is about, again, your solids, this is about your liquid, but in these two things, potential difference or charge, not charge, potential difference is being generated. Clear, everyone? Hello.
Yes, ma'am.
Everyone?
Yes, ma'am.
Okay, very good. Now I told you all about zeta potential. It will help in determining zeta potential, zeta potential. So what is actually zeta potential? Let us look into it. So whenever you have your dispersed systems, right? Dispersed system, matlab, let us assume a standard one wherein, excuse me, let us assume a standard one wherein you have a solid in liquid type of dispersion, a suspension. Yeah, you have a suspension, which is nothing but solid in liquid. All right. So in that case, तुम्हारा solid पे कुछ ना कुछ तो charge होगा ही. Say if it has a negative charge or a positive charge, it will have some charge on it. Okay, ये solid का खुद का charge है. Now when you disperse it in liquid, तुम्हारा water जो simple है वो भी क्या होता है? H plus OH minus, correct? So you have negative moieties also, you have positive moieties also. So if your solid, this is your solid surface, okay? This is your solid surface. If this is pura positive, then this will be negative. All right? It will be, there'll be more negative ions here. In this region, a little far away from that region, okay? And these are closely associated. They are like, बहुत ज़्यादा association है खुद में. All right? Positive, negative, attract, correct? Positive, negative, attract. So there's a very close association. So when you apply shear also ना, जब कुछ movement भी apply करते हो, when you apply shear also ना, ये पूरा region move होगा. हमें लगेगा कि सिर्फ solid पे shear लगेगा, but नहीं. ये वाले region को भी shear लगेगा because it is so closely associated. And that is why this region is called as the shear plane region. Okay, so this is the solid surface. This is called as the stern layer. Okay, and this will help in determining the potential. Hence, it's the potential determining ion. And that region, okay, so this is the one. ये तुम्हारा solid surface है. This is the region जो तुम्हारा stern layer है, which is already attached. The natural charge of the solid. And that is going to determine your potential. And ये जो मैंने region बोला जो shear के वजह से भी हिलेगा, because it is closely associated, that is called as a shear plane region. And the ions present there are called as counter ions or Jejin. Counter ions why? Because तुम्हारा natural potential determining ion अगर positive है, तो उसका counter माने उसका opposite क्या होगा? Negative. Now, when you move a little far away from the shear plane region, you will have this region जहाँ पे there'll be negative and positive both, but there will be more of negative. Okay, there will be more of negative. And these both layers become the diffuse double layer. और जो ये last region है, that is electrically neutral layer. क्योंकि वो it becomes the bulk. It becomes the bulk. There's a uniform distribution here. So it becomes an electrically neutral layer. So samjha, this is your solid surface, this is your stern layer, this is your shear plane layer. Then both of these become your diffuse double layer, and this is your electrically neutral layer. Fine. So when you measure a potential difference between the stern layer and the electrically neutral layer, okay, when you determine the potential difference between the actual surface, that is the stern layer, and the electrically neutral region, matlab ye A to A region and D to D region, iska potential difference jab you measure, that potential difference is going to be the Nernst potential or electrothermodynamic potential. Whereas the next one, which is the potential difference between the shear plane region and the electrically neutral region. This is your zeta potential or the electrokinetic potential. And it is important to study the zeta potential to understand the physical stability of your colloidal particles. Because it is studied that a zeta potential of beyond -2 plus of greater than plus or minus 30 millivolts, इसका unit is millivolts because ये charge है, right? Potential difference है, so volts. Zeta potential of more than or equal to plus or minus 30 millivolts will give you a stable suspension, physical stability. So this is your number scale, correct? ये 0 है, ये 10, 20, ये 30 है. Okay? And similarly, the -10, -20, -30 hai. So it should be beyond this. Should be beyond this. Iske beech mein hoga na. So this is not stable. It should be beyond -30 or beyond +30. Then we say it is stable. Because ye tumhara do suspension hai. This is in emulsions also. Abhi isme there is thoda charge. Thoda minus negative charge. But still there is some positive charge here, right? So there will be some attraction. But imagine in another case, there's a lot of negative charge. Lot of negative charge. So there will be a repulsion. There will be repulsion. And this is what we want for physical stability. Because agar ye hua, attraction hua dono ke beech mein, so it can lead to aggregation. And aggregation hua to you will lose the many things, lose the basic properties, right? So that is why it becomes important. Did everyone understand zeta potential? It's very important. Very important. Understood? Any doubts here? नींद में भी अगर कोई तुम्हें पूछेगा तो बोल पाओगे? Hello.
Yes, ma'am.
Okay. Next, moving on to another important property of colloids, which is the gold number. And I'm telling you, zeta potential gold number. This is important with respect to your GPAT NIPER also. Okay? These are important. So now, it is observed that when you have these hydrophobic colloids. So tell me, hydrophobic colloids are lyophilic or lyophobic? Hydrophobic colloids are lyophilic or lyophobic?
Lyophilic.
What?
Lyophilic.
Very good. Okay. So your hydrophobic colloids now, what happens? They are a little unstable in nature when we speak about water as a dispersion medium, because anyway they are hydrophobic, right? So that is why they are unstable and they tend to coagulate. Because suppose if you keep something which is hydrophobic in water, तो वो molecules का एक दूसरे के साथ तो अच्छा बनता है, water के साथ अच्छा नहीं बनता ना. So imagine if you are kept in a family function where you and your cousins are enjoying, but then you all are not, like, you all get bored with the elders in the family. So what will you all do? You will tend to stay with the group of cousins, right? You all will be coagulated because you all are hydrophobic with respect to the environment, correct? So that is why these hydrophobic colloids, when present in water, they tend to coagulate. They are unstable. So in order to stabilize them, you will add large amounts of hydrophilic colloids. Okay. To stabilize them, you will add hydrophilic colloids. And these hydrophilic colloids, they give a protective action. Okay. They protect these hydrophobic colloids. There is a protective action. And this protective action of hydrophilic colloids is measured in terms of gold number. तो तुम्हारे हाइड्रोफिलिक कोलॉइड्स को in this case you all can call it as a protective colloid and the degree of protection is expressed in term of gold number. But यहाँ पे relation उल्टा है कि as the gold number increases the protective action decreases. Okay, as the gold number increases the protective action decreases. So in this example, tell me which protective colloid has the highest action. जितना गोल्ड नंबर ज्यादा होगा उतना प्रोटेक्टिव एक्शन कम होगा. तो टेल मी विच प्रोटेक्टिव कोलॉइड हियर हैज द मैक्सिमम प्रोटेक्टिव एक्शन.
Gelatin.
Gelatin.
Why? Why gelatin?
Its gold number is less than other.
Yes, because it has the least gold number in this list. It has the least gold number. That is why gelatin acts as a very good protective action, protective colloid. And these all protective colloids, again, I'm telling you, they are hydrophilic in nature. Fine. And which one has the least protective action?
Ragakant.
Ragakant. Why? Because uska gold number सबसे ज़्यादा है in this list. All right. So this was about colloids. With this, we complete the chapter of colloids. I shall upload the assignment also by the end of the day. Fine. And okay, now we shall solve MCQs. Before that, any doubts? Anyone? Hello. Any doubts?
No, ma'am.
Okay, so can we solve the MCQs?
Yes.
Do you all have the MCQ booklet for this? Hello. Hello. MCQ booklets है तुम लोग के पास?
Yes.
Yes, ma'am.
Okay, great. So open your MCQ booklets. थोड़ा order ऊपर नीचे हो सकता है. So we'll solve it from your MCQ booklet. In case if there's a question which I don't present on screen, let me know by the end. Fine. So tell me if you all can. Tell me if you all can see the screen. Can you all see the screen?
Yes.
Great. All right, fine. So the first question. What does the Greek word cola refer to? And these are your options. 1 minute. Yeah. What does the Greek word cola refer to?
B colloids.
Yes, the answer is B, colloids. The others are Latin names for your drugs. All right. Next, drugs, that is your cola and coca, unke wo Latin names. These questions are there in your books, right? Hello. Hello.
No, ma'am.
Okay.
No, ma'am.
These are not there in your books.
No.
All right. Fine. Anyway, so we will solve the book wale MCQs also later. Maybe today only or next class. So you all will have more MCQs to solve. Which of these are generally colloidal?
All of this.
Okay. I want everyone to answer. You all can also answer through the chat box.
All of these.
Why all of these?
Because they are the examples of
Justification as well.
colloidal.
What?
Examples of colloidal solutions.
Exactly. All of these. So yeah, the correct answer is all of these. All of these can form colloidal solution. Emulsions can be coarse also. They can be coarse also, but yes, they are colloidal as well. Fine. So the correct answer is all of these. Moving on to the next one. Which of these are colloids? Again.
All of this.
All of these.
Yes.
Why?
Because it is the example of colloidal solution, paint, glass, and blood.
So all of these are colloids? यहाँ पे multiple, okay, the hint is यहाँ पे there are multiple answers.
D paint, F blood, and C butter.
Blood, paint, and
Butter.
what is the justification?
Butter is an emulsion and
Continue, Khushi.
paint is an example. I have read, I can't recall, ma'am.
Paint is also a dispersion. It's kind of a sol dispersion. Sol or suspension तुम बोल सकते हो.
Blood is
Then-
also some types of suspensions.
Blood मैंने बोला ना, it's a complex dispersion. उसमें भी colloidal moieties आती है. So yes. What is brine? All of these तो नहीं है. ये option इधर ही eliminate हो गया. What is brine?
Yeast solution.
Brine is NaCl solution. Okay, but the point is that brine is a solution. It's in the molecular level. What is brass?
It is an alloy.
And what are alloys?
Mixture of two components.
Barabar bolo. Alloys are nothing but a homogeneous solid solution of metals. When you melt two metals and mix them homogeneously to form a solid solution, that is an alloy. Okay, so even this is a solution. And muddy water kya hua? Mud ko tumne water mein mix kiya, so that you can see through your naked eyes na, so that becomes a coarse system. So that is why these three are not the options, and the correct answers are C, D, and F. Clear, everyone?
Yes.
Yes, ma'am.
Okay. Next, question 4. Aerosol is what dispersion?
Gas in liquid.
B.
Huh?
Gas in liquid.
Then what is foam?
Liquid in gas.
See, मैंने बोला है aerosol में your dispersion phase becomes gas, and foam में your dispersion in aerosol, your dispersion medium is gas. Medium is gas. Okay, so gas में you will have things, and foam में gas becomes your dispersed phase. That is this. So now tell me, what is aerosol?
Liquid in gas.
Pakka?
Yes.
Yes.
Everyone understood this?
Yes, ma'am.
And what is a solid aerosol or a suspended aerosol? Solid in gas. समझा?
Yes.
Aerosol बोला तो gas becomes your medium. Question 5. What is foam? What is foam?
Gas in liquid.
Gas and liquid.
Correct.
and liquid.
Now this is a solid foam or a liquid foam?
Liquid form.
Okay. This is a liquid form. What is a solid form?
Gas and solid.
What is the example? Sponge. इसका एग्जाम्पल क्या है? सर्फेक्टेंट सॉल्यूशन. सो के आए हो क्या आज? What's wrong? Are you all there mentally?
Yes, ma'am.
समझ आ रहा है तुम लोगों को?
Yes, ma'am.
Is it very difficult? Are you all having some confusion? Please tell me now only. Any difficulties? Hello.
No, ma'am.
Okay. Which of these is not a purification technique? Bolo, which of these is not a purification technique?
Electrodecantation.
Didn't I explain you electrodecantation with electrodialysis?
Yes. Ultrafiltration.
अल्ट्राफिल्ट्रेशन भी नहीं था. What about the others? Why aren't you all answering? तुम लोग पढ़ के नहीं आए हो मतलब. What is the point of providing your notes before the class? You all didn't study, right? Huh?
Ma'am, all of these are purification techniques.
So the answer is
E.
exactly. Dialysis we studied. उसके basis पे we studied electrodialysis. उसके basis पे I also explain your electrodecantation. And then ultrafiltration. जिसमें एक बार फिल्टर लगा के एक बाजू से प्रेशर डालते हैं. याद आया? There were 3 techniques.
Yes.
And इधर नीचे electrodecantation भी लिखा था मैंने. Please study यार. What we'll do, we'll just take up these MCQs. The remaining MCQs, maybe we'll you all do it by yourself. And then if you all have doubt next class, मुझे पूछो. Correct? Will you all do that?
Yes, ma'am.
Which of these form colloidal dispersions readily? Huh?
Lyophilic colloids.
Pakka.
Yes.
Correct. Lyophilic because they already like the dispersion medium. They have affinity for the dispersion medium. So they will readily form by the technique of simple dispersion itself. Correct? ज्यादा मेहनत कौन से उसमें लगती है बनाने को?
Lyophobic.
Lyophobic में. And what are your association colloids? What are association colloids?
Surfactant associate to form micelles.
Correct. Surfactants which associate to form micelles. Thank you. I can just hear 2-3 voices. That's it. Protective colloids are
Hydrophilic colloids.
Hydrophilic colloids.
and whom do they protect? किसको protect करते हैं?
Hydrophobic.
Hydrophobic colloids.
Hydrophobic को protect करते हैं. Okay. I think some of these MCQs are there in your book. So when you all are going to solve the MCQs from the booklet, कुछ repeat होंगे, कुछ नए होंगे. So please do it by yourself. Next class we will solve that. So for the next class तुम लोग अभी से solve करो. I think that is your assignment. That is your assignment. Please do that. Gold number of colloid and its protective action are what?
Inversely proportional.
Inversely proportional.
So as gold number will increase, the protective action will
Decrease.
good. What is peptidization?
Methods of preparation of colloids.
Correct. Can you explain me how is it prepared? In your own words.
Addition of electrolytes.
And
Precipitation of the common ion.
so a precipitate is formed. Say अगर मैग्नीशियम सॉल्ट का प्रेसिपिटेट बना है, तो तुम कौन सा आयंस यूज करोगे?
Magnesium.
सेम आयंस यूज करोगे.
Yes.
And then we will shake it. And then what will happen?
Precipitation of magnesium.
Precipitation नहीं होगा. Precipitate से it will be dispersed. It will form smaller size colloidal range and it will be like उस पे किसका कोटिंग लग जाएगा? दिस मैग्नीशियम का. एंड सिंस मैग्नीशियम इज 2+, Mg2+ होता है ना,
Yes.
तो उस पे पॉजिटिव चार्ज आ जाएगा एंड दैट इज हाउ इट विल बी स्टेबलाइज्ड. करेक्ट?
Yes.
ओके. Which of these is not a property of colloids?
D.
Correct.
Flocculation.
करेक्ट. वो इंस्टेड किसका है?
Suspension.
ओके. So this is the answer. Flocculation suspension में भी होता है, emulsion में भी होता है. When we study emulsion, I'll explain you all there. Okay. Which of these does not form a dispersion?
Gas.
Gas.
And
Gas.
Why doesn't it form dispersion?
Because it is miscible.
Visible.
Miscible with each other.
Miscible. You can say because it does not have an interface. याद आ रहा है surface and interfacial tension? Okay, because it does not have an interface, there is no boundary between the two, and because there is no boundary between the two, they cannot be separated, and because they cannot be separated, it cannot disperse, and that is why they mix with each other. Solid in solid को क्या बोलते हैं? Solid in solid को solid dispersions बोलते हैं. Liquid in liquid को
Emulsion.
emulsions. Fine. And gas in solid ko again
Solid form.
solid form. Thank you. All right, so these were your MCQs. Now for colloids, what are you all going to do? Just a minute. कि अभी कर देना है MCQs. What do you all want to do?
We can do as an assignment.
Okay, fine. इसमें colloids का नहीं है क्या MCQs? तुम लोग की बुक में देखो colloids का MCQs नहीं है.
है मैम.
कौन सा चैप्टर है वो?
Colloids.
हाँ, चैप्टर नंबर क्या है तुम्हारे MCQ बुकलेट में?
2.
2.
Yes.
I'm not having that. Anyways, what I'll do is I'll arrange it for myself also. I don't have the final copy of this. What is the first question in that?
What are salts?
Acha. There are 12 questions, correct?
Yes.
Yes, ma'am.
Okay. What are salts? Then colloids are classified based on what? Correct? वो सब है ना?
Yes.
Acha. This MCQ booklet you all have. Fine. ठीक है. So you all do these 12 MCQs by yourselves. We shall study it. We shall discuss it at the beginning of the next class. Fair enough. But आज जो भी किया वो समझा तुम लोगों को?
Yes.
क्या?
Yes, ma'am.
Okay, fine. What we'll do is we've got some time. So we'll discuss begin with coarse dispersions as well. All right. Fine. So we are done with colloids. All right. The chapter is over. Now we'll begin with coarse dispersions. So what do you understand by coarse dispersions? Come on, what do you all understand by coarse dispersions?
Aggregation of the particles to form a coarse.
क्या?
Aggregation of smaller particles to form the coarse.
So coarse dispersions are nothing but your dispersions only of the coarse size range. Correct? We studied 3 major classifications, right? So उसमें से one with इसका size range क्या होता है? What
More
is the
than
size?
micrometers.
More
More
than
than 1 micrometers.
more than 1 or 5, you can say micrometers. Fine, these are your coarse dispersions. So in this topic, it's divided into 2 parts. The first part will be dealing about the coarse dispersion with respect to suspensions. Okay. So this topic actually comes under physical pharmacy. So usme kya hai ki we will understand how the dynamics behind these things work. And when we study suspensions in pharmaceutical aspects, tabhi we'll understand its application. How do you make it and all of that. Fine. So in the first part of coarse dispersion, we will be studying about the mechanisms and the signs, the thermo aspects of the suspensions. In the second part of coarse dispersion, we'll discuss about emulsions. So what I'm thinking of doing this time is that we will do it parallelly. Always I used to teach coarse dispersions together, suspension and emulsion ke saath. This time, so that for you all to have a better understanding, I'm thinking मैं coarse dispersion का suspension वाला part पहले समझा दूं, and then we will discuss suspension का formulation aspect. So you are done with suspensions. Later on, we will discuss about coarse dispersion का emulsion theories, and then emulsion as formulations. Will that be better? Is that fine with you all?
Yes, ma'am.
Yes, ma'am.
Instead of doing entire coarse dispersion together, I think let us complete one topic all in all. All right. So right now we'll start this suspension wala part. After this, we'll take up pharmaceutics ka suspension. Then we will solve its MCQs, and then we will begin with the remaining part of coarse dispersion and emulsions. Fine. So in this first section, we are going to discuss about suspensions as coarse dispersion. Uska application kya hai? What should be the desirable properties of your suspension? Then the physical aspects, that is uska interfacial properties kya hota hai, what are the associated Gibbs energy to it, settling of the suspension kya hota hai, uska formula, and the important part of flocculation and deflocculation. There are another important aspects of Oswald rightening that we'll study in later ahead. Fine. So this is an extension, okay, under the umbrella of dispersed systems. As I told you, one, you have your molecular, then you have your colloidal, and then you have your coarse. And coarse may, all in all, for pharmaceutical use, broadly, you have suspension and emulsion. So suspension becomes your solid and liquid, emulsion becomes your liquid and liquid. And जो भी novel drug delivery systems होते हैं वो usually colloidal में आते हैं, तुम्हारे nano particles and all of that. हाँ, one of the important novel drug delivery system which are called as microspheres, they come under the category of coarse dispersion, microspheres. And microspheres are nothing but solid and liquid. They are bigger size range of nano, I won't say nanoparticle, microparticles, which are dispersed in liquid. And इसमें तुम्हारा आ गया nanoparticles आ गया, liposomes आ गया, micelles आ गया, all right, SMEDs आ गया, then you have your salts. All of these comes under your colloidal size range. So molecular में we will, did we do solution and colligative properties together? और liquid dosage form हमने किया है?
No, ma'am.
No, right? So this will take up at the end. Okay, इसमें important is to understand the liquid dosage systems, which will take up at the end. We've already discussed about the colloidal systems, and now we shall proceed discussing about the coarse dispersions. So as I told you all earlier, coarse dispersed systems are made of dispersed phase and medium, wherein you have molecular, colloidal, and coarse. Fine. So this is to be done in future. This is done, and now we'll be discussing this. Fine. And isme, as I told you, you have emulsions and suspensions. So coming to suspensions, suspensions are nothing but your solid particles dispersed in liquid media. And this is how they behave internally. What are they undergoing? ये क्या हो रहा है इधर?
Brownian motion.
Very good. They are undergoing Brownian motion. All right. And these have a diameter greater than 1 micron, hence coarse dispersion. And these exhibit Brownian motion when the viscosity is low. जो हमने अभी at the beginning of the lecture discuss किया. Viscosity, concentration and temperature. Viscosity and concentration के साथ it's inversely proportional. Temperature के साथ it is directly proportional. Correct? So even these will experience Brownian motion, but only at lower viscosity. Correct? So this is about suspension. Now, why is it important to understand suspension for pharmaceutical use is that suspensions become very important in administering drugs which are insoluble or poorly insoluble. I told you all, pharmacy mein the best formulation is drug plus pani. कुछ भी अगर ड्रग प्लस पानी में मिला के दे दो, इट्स सो इजी टू फॉर्मुलेट, सो इजी टू एडमिनिस्टर. प्रॉब्लम कब आने लगती है? व्हेन योर ड्रग इज इनसोल्यूबल. प्रॉब्लम्स कौन सी होती है? व्हेन योर ड्रग इज इनसोल्यूबल और पुअरली सोल्यूबल, व्हेन इट हैज स्टेबिलिटी इश्यू, हाइड्रोलिसिस हो गया या ऑक्सीडेशन हो गया. ओके, all these issues, say, then we go on to another formulation, improved formulation. So in case when you have this problem, insolubility, you will simply disperse the drug in a medium. So that is when it forms a suspension. So suspensions are a very critical formulation for administering drugs which are insoluble or poorly insoluble. All right. It becomes important then. Then because of this, higher drug dissolution and bioavailability is there in compared to other formulation. Now suspension suppose nahi bana sakte, then you will go on making tablet. First I told you the best is solution, then is suspension, then is tablet, then is capsule, and then तुम्हारा अगर कुछ और हुआ तो हुआ. So now tell me, इसमें से सबसे high and सबसे fast bioavailability किसकी है? And this is for oral, huh? I'm not talking about parenteral. Parenteral will have 100% bioavailability. Correct? If you give it through IV route. Intravenous मतलब directly blood में दिया तो 100% bioavailability and immediate action होगा. But for oral use, tell me इसमें से सबसे ज्यादा bioavailability किसकी होगी? सबसे ज्यादा and सबसे fast?
Solution and suspension.
Solution की होगी. First number solution का आएगा. Why?
Is already in liquid form, so it is absorbed faster.
It's already in molecular level. वैसे बोलो. It's already in molecular level. That is why it will पटाक से it उसको dissolve होने का step का जरूरत नहीं है. But your suspensions, are they in molecular level? Are suspensions in molecular level? These
No,
are some
ma'am.
important MCQs. If not molecular level, then they are in their which level?
Granules form.
Particulate. Okay. Particulate level पे है. So particulate. So ये solution में जो molecular level पे है, it will directly undergo absorption. यहाँ पे particulate level पे है. So first it will have to undergo dissolution. तुम्हारे GI fluids में dissolve होना पड़ेगा and then it will be absorbed. अभी tablet में तुम्हारा compressed form में है. Okay, you have your tablet powder जो पहले granules बनाते हैं and granules से you become it forms a tablet. So पहले in order to dissolve ये tablet को पहले break होना पड़ेगा, बाद में granules को dissolve होना पड़ेगा. Dissolve मतलब हाँ, granules को dissolve होना पड़ेगा and then it will have to undergo absorption. Capsules में और भी it will take time. Okay. Actually, capsules come before tablet because capsule में the drug is in powder form. Capsule is faster than tablet because capsule में shell dissolve हो गया तो drug को बस dissolve होना है and then it will be absorbed. Tablet में tablet को disintegrate होना है, then granules को disintegrate होना है, then dissolve होना है, then absorb. So in compared to capsule and tablet and even coated tablet में और time लगेगा. So compared to all these, you have a higher dissolution and bioavailability in suspensions. Agree? Agree,
Yes.
everyone? Yeah.
Yes, ma'am.
So this is the thing. Then suspensions also become important with respect to parenteral. Many of your parenteral suspensions are also parenteral formulations are also suspensions. They are given through intramuscular route, subcutaneous route. They help in forming depot systems. So वो सब novel parenterals में आता है. That we'll discuss in detail when we study parenterals. Then ophthalmic formulations में you have suspensions. All right. Then your topical formulations. Your topical formulation, your creams and all. Okay. So parenterals, ophthalmics, topical formulations, your creams and all, some of them are suspensions. Veterinary products में suspensions आते हैं, and your जो भी pest control के जो chemicals और वो सब होते हैं, even they are in their suspended form. All right, so suspensions have a wide applicability in your pharmaceuticals. And these are some properties which are thereby desirable in a suspension. Okay, your suspended particles should not settle rapidly. If they settle rapidly, okay, your suspensions should not settle rapidly. If they settle rapidly, that means it will form a hard cake. And suppose settle होने के बाद if it forms a hard cake, मतलब its property lose हो गया. You will lose that drug, and वो drug का जो therapeutic effect आना चाहिए वो नहीं आएगा, because less amount of drug will be reaching your system. So suspended particles should not settle rapidly. That is why to prevent this, you add suspending agents, correct? To keep them suspended for a longer period of time. So here, Brownian motion का optimal होना चाहिए. Next is particles should be readily redispersed into a uniform mixture when the container is shaken. So even if it is settling, it should not form a hard cake. Okay, it should not form a hard cake, and instead shake करने पे it should readily redisperse. And redisperse भी कैसे होना चाहिए? Uniform होना चाहिए. So every time you take out the dose, you have same amount of particles or same amount of suspended matter coming out. If it's not uniformly dispersed, तो only the supernatant will come out. Drug उधर का उधर रहेगा. तो कभी you will get 5 mg of drug, कभी you will get 10 mg of. All right. So this is a very important point. Then particles that settle at the bottom should not form a hard cake. I already explained you all. If it forms a hard cake, that is drug loss. If it happens, that is drug loss. Sorry, loss. And you lose therapeutic activity, lose the bioavailability and the therapeutic activity. Next is the suspension must not be too viscous. Thoda viscous hona chahiye for the particles to remain suspended. Tell me, if viscosity zyada hai, to Brownian motion kam hoga, correct? Or Brownian motion viscosity kam hai, to settling zyada hoga ki kam hoga?
ज़्यादा होगा.
Viscosity कम है तो settling ज्यादा होगा. So viscosity भी optimal होना चाहिए, because अगर ज्यादा viscous होगा, it will be difficult to administer to the patients also. Imagine if your eye drops, suspension eye drops are too viscous, or imagine taking out a very viscous thing out of the bottle of your suspension. So this must be optimum. All right. And then it should have an acceptable color and odor. All your oral formulations, they must be acceptable visually, and उसका palatability भी अच्छा आता है. इन properties को क्या बोलते हैं? Organoleptic properties. Organoleptic properties में taste, color, smell, ये सब आता है. Fine. So all these acceptability should be there. These are the important and desirable properties of your oral suspension, especially. All right. So I think we can end over here for the day. In the next class, we will start with understanding the interfacial properties of your suspended particles and carry on from there. Also, we'll discuss those MCQs. जो 12 MCQs है वो. Understood, everyone?
Yes.
Yes.
Any doubts? Any concern? So तुम लोग के पास colloids के notes आ गए हैं and coarse dispersion का pre-read आ गया है. So just go through it. Fine. After I complete this chapter, I'll give you all notes of this. Yeah, tell me. Pragnya?
I was saying no doubts.
Okay, fine. Chalo, let's end for the day then. Bye-bye.
Thank you, ma'am.
Yeah.
Thank you.